Hi, Srivali.
Hi, Shanti.
So let us discuss today about the RAG architecture. So what is
Mhm.
RAG architecture? The acronym is Retrieval Augmented Generation is an AI framework that improves the quality and accuracy of large language model LLMs responses by retrieving relevant information from an existing knowledge base to supplement the LLM's internal knowledge. It has two components, retrieval and generation. See, what is retrieval? Algorithm search for retrieve snippets of information relevant to the
Mhm.
user's prompt or question for an external knowledge. This
Mm.
could be indexed documents on the internet or for open domain settings or a narrower set of trusted sources for closed domain enterprise use case. Generation is the retrieval information is applied to the user's original prompt and passed to the LLM. The LLM then draws from the augmented prompt and its own training data to generate a tailored, engaging answer for the user. See, when you design the LLM, there are two ways. One is through the internet, it can get the information and
Mm.
give the knowledge. Okay.
Mm.
Next one is we have created some database, historical database. From that database also it can do that. Now let
Mm.
us say you take doctor's robot, okay, or chatbot. There is a chatbot.
Mm.
Its name is Doctor Chatbot. Okay,
Mm.
so the doctor is that can be general practitioner or it can be uh, orthopedic. It can be any kind of specialization, right? So
Mm.
that chatbot can be created. One is with the internal experience database for different symptoms identification,
Mm.
or it can have connection with the internet to pull the information through ChatGPT or some other tools like OpenAI tools are there, and it can compile and give the answers. So
Mm.
now what we are doing in reality, we are writing AI prompts for our regular work, and that prompt is executed by LLM. It can be
Mm.
ChatGPT, it can be Merlin, it can be some other tool, any tool, right?
Mm.
That tool, what it is doing internally, it is going to search in the Google search, right? It is
Mm.
going to compile all the links, around 20 or 30 links, and it
Mm.
brings the best information for us after compiling, right?
Mm.
That kind of functionality is there in the retrieval part. R means retrieval.
Mm.
Then augmented generation is, let us say, the orthopedic surgeon has got tremendous experience and he has got many patients' data. All the data they might have fed it.
Mm.
Then it can generate from the internal data some kind of advices to the patient.
Mm.
It means when you are creating information, when you are creating the LLM for a chatbot or any other application, you need to decide it whether you are using RAG. Okay, if you are using RAG, LLM is going to be effective. It will be working faster, right? That is the benefit. Here, what are the benefits? We'll see. Let us see here. Providing LLMs access to the most current, reliable facts beyond their static training data. What is static training data? Whatever database we have kept it for accessing by the LLM for internal data, that is the static data. Allowing users to verify the accuracy of LLM's responses by checking the cited sources. So the sources you can give it like from this site you can get the information like that list of the sites to the LLM also that guideline also kept it. So the RAG is allowing that retrieval of the information, then reducing the risk of LLMs hallucinating incorrect information or leaking sensitive data. Let us say one is hallucination is there can be some kind of um, wrong information or exaggerated information, such kind of things. So then that should not be shown to user. Example, okay. Then leaking sensitive data. Sensitive data is related to patient severity. Such kind of things are having privacy, patient data. Then you should not. So all those things are controlled by the RAG basically. The benefits. So it means privacy wise also it is going to work. Then RAG is a cost-effective ways to adopt generative AI models to specific domain or organization knowledge base without the need of full retraining. It means if you use the RAG, your retraining effort is going to be reduced rate because RAG has got some mechanism how to use internal data, how to use external data. Then it compiles and gives the fine-tuned information with consultation, like how ChatGPT is giving to us with a lot of information. Or if you take some other tools, it will give with references of the URLs also. You saw that, right?
Mm-hmm.
So it improves the consistency, accuracy, and trustworthiness of LLM-powered applications like chatbots. Yes, this is the thing. Okay, chatbots purpose we are going to use. Next one is what are the cost benefits of using RAG over retraining models? Using RAG offers several cost benefits compared to traditional model retraining or fine tuning. Here are the key advantages. Reduced training cost. RAG doesn't require an extensive computational resources and time associated with retraining models from scratch. Instead, it leverages existing language models and enhances their output by retrieving relevant information from external knowledge base. This significantly lowers the cost related to model training and maintenance. See, this particular LLM, it is going to be used by the OpenAI connectivity. In the OpenAI connectivity, it can pull the information from any kind of tool. Okay, you have
Mm-hmm.
OpenID, connection ID, account is there. That account need to be plugged in there with the LLM to go and use it. So you have designed such a way that then what happens? Immediately you will get the information, like how you are getting from the ChatGPT, right?
Mm-hmm.
Then dynamic updates. RAG allows for real-time access to up-to-date information without needing to retrain the model every time new data becomes available. How new data becomes available means it has got connectivity with LLMs, okay, like ChatGPT, other things. Okay,
Mm-hmm.
this is particularly beneficial for applications that rely on rapidly changing data, as it eliminates the need for frequent and costly retraining sessions. We don't need to prepare massive data to train that model and test that model also. So it collects the data basically. Okay. Then flexibility and adaptability. RAG systems can easily adapt to new information and context by simply updating external knowledge sources. This flexibility reduces the operational burden associated with maintaining a fine-tuned model, which can become outdated quickly and requires significant resources to update. Now, if you are not using RAG or old before RAG, what would have been there? There would have been internal trained data, then that data is getting fed every time.
Mm-hmm.
Then you need to change the version of the data every week or something, depends on the live data. So with the live data you are training the model, then you are going to host that as remodel or modified model or something, right?
Mm-hmm.
As per the ML life cycle, right?
Mm-hmm.
But
Yep.
if you use RAG, everything is going to be faster, and it has accuracy also comparatively with manual prepared data, right?
Mm-hmm.
So minimized hallucinations. RAG reduces the risk of hallucinations, the generation of incorrect or nonsensical information by grounding responses in retrieval evidence. Obviously, the OpenAI tools will have privacy maintenance for the data. If it is confidential information, it won't give it. Right? We saw that, right?
Mm-hmm.
This leads to more reliable outputs without the need for extensive retraining to correct inaccuracies, thereby saving cost associated with error correction and quality assurance. So, all these things are time saving activities. Your testing effort is going to be reduced. when you
Mhm.
remodel it. That is the advantage. Okay. Then lower resource requirements. Since RAG can work effectively with smaller models by augmenting their capabilities through retrieval, it can lead to saving in cloud computing expenses and hardware procurement. Obviously, RAG is going to work like high-end computation way also to get the data, finalize the model also. It means it is very fast. Smaller
Mm.
models typically require less infrastructure, which translates for further cost savings. So it saves a lot of efforts at the same time infrastructure cost also. In summary, RAG provides a cost-effective alternative to retraining models by enhancing their performance through dynamic information retrieval, reducing the need for extensive training resources, and ensuring that models remain relevant and accurate in changing environments. So you can keep on scaling up with multiple data files, also multiple data sets, also. Okay, that way,
Mm.
right? Scaling is faster.
Mhm.
So, what are the limitations of RAG in adapting to domain specific knowledge? RAG has several limitations when it comes to adapting to domain specific knowledge. One is fixed passage encoding. In its original implementation, RAG doesn't fine tune the encoding of passages or external knowledge base during training. This means that while it can retrieve information, the underlying representations may not be optimized for specific domains, potentially leading to its relevant or accurate responses in specialized context. If you want in a presentation mode, you may not get immediately. You need to do formatting. That
Mm.
formatting purpose, you need to transfer that data into particular staging. Then that from that staging, you need to write the Python program and fine tune the data and present it in the dashboard.
Mm.
That is not called as a disadvantage, but we need to customize the application basically. Okay, then
Mm.
computational cost. Adapting RAG to domain-specific knowledge bases can be computationally expensive. Why it is expensive? Because you are supposed to take the connections with some kind of
Mm.
gateways, OpenAI gateways, right?
Mm.
Updating all components, including the external knowledge base and retriever, requires significant resources. Yes, obviously. This can deter
Mm.
organizations from implementing RAG in domains where frequent updates are necessary. If you want frequent updates, yes, it costs a little bit. Yes, it is going to get accurate information,
Mm.
right? That is benefit. Okay, because we need reliability also. So, third one is limited understanding of domain-specific context. RAG's performance in specialized domains such as research papers or news articles is not well understood. So those domains are different because research articles they publish it, but on the internet, if it is new article,
Mm.
very few information will be there to compare and compile it, right?
Mm. Mhm.
Then at the in that position, we have to see how to customize that. The model may struggle to accurately interpret or generate responses based on domain-specific nuances, which can affect the overall quality of output. Obviously, these are constraints only, not the disadvantage or something. Hallucination risk. While RAG aims to reduce hallucinations by grounding responses in retrieved information, it can still generate plausible sounding but incorrect information if the retrieval context is not sufficiently relevant or accurate. It means unrelevant information also it can bring sometimes, but
Mhm.
somebody need to filter it. Okay. This risk is particularly pronounced in domains where the model has not been specifically trained or fine-tuned. Yes. Then context window limitations. RAG must operate within the constraints of the context window of LLM, which limits the amounts of retrieved information that can be effectively utilized. This can restrict the model's ability to incorporate comprehensive domain-specific knowledge into its responses, especially if the relevant information exceeds the context window size. Yes. Summary is while RAG provides a flexible approach to integrating external knowledge, its limitations in fixed passage encoding, computational demands, understanding of domain specific context, risk of hallucinations, and context window constraints can hinder its effectiveness in adapting to specialized knowledge areas. If you want to prepare some chatbot for latest information, to get the latest information on anything, this may not be the right picture to utilize this RAG architecture. So other things, yes, regular operations, developed technology or developed things, yes, you can use it. That is
Mm.
the difference. Okay.
Okay.
Right. Now let us stop this recording.
Yeah.